Welcome to our lesson on integration of functions in the form 1 over x and then 1 over ax plus b. So let's take an example. If we are told to integrate 1 over x, how shall we go about it? Let's say we want to try with the normal integration. So we have we can rewrite 1 over x as x raised to the power -1, right? Then we integrate, we add 1 to the power and then we divide by the same thing down here. So we have -1 plus 1, we have -1 plus 1. That gives us x raised to the power 0 over 0, which is the same as 1 over 0. And 1 over 0 is undefined, so there's a problem. The problem is that we cannot integrate directly like this. So what do? Right, so recall that from our study of differentiation, how to differentiate logarithmic functions, I have a video on that. So if you don't know, I would urge you to take a look at the video. Okay, so to differentiate ln x, we said the answer is 1 over x. Okay, so whenever we differentiate ln x, we get 1 over x. Right, so what if we integrate both sides of the equation? All right, so we apply integration on both sides. So when you apply integration on d dx, you get the function, okay? So you get ln x. Then we have the integral of 1 over x dx. Therefore, when we integrate 1 over x, our answer is ln x, okay? Plus c, and it's plus c because this is an indefinite integral. All right, so the first rule for today is that whenever we integrate 1 over x, the answer is ln x. Okay, so we have an example. We want to find the integral of 8 over x dx. Right, so the first thing we would want to do is to pull out 8. Okay, so let's pull out 8. When we do that, we have 8, the integral of 1 over x, and we said 1 over x is what? Ln x. Okay, so we have 8 ln x plus c. See, very simple. Let's take another one. Example 2. We have the integral of 1 over 2x dx. So this one too, we can factor out half. Okay, so we will factor out half. When we do, we are left with 1 over x, and we said 1 over x is what? Ln x. Okay, so 1 over x is ln x, so half times ln x will give us ln x over 2, okay, plus c. Very simple. Right, how about when we have 1 over ax plus b? Okay, so recall from our study of logarithmic function, we said that if you have ln ax plus b and you are to differentiate, your job is to differentiate this ax plus b, and that gives you a, and then you divide by the ax plus b. Okay, so you differentiate ax plus b, you get a, you divide by ax plus b. Right, so how about when we apply integration on both sides of the equation? Like I said, the integral of d dx gives you the function, so that gives you ln x. Then the integral of a over ax plus b dx. Right, so let's factor out a, okay, the numerator. So when that happens, this becomes 1, okay, so you have 1 over ax plus b, like what we are trying to solve. Okay, good. So the integral of 1 over ax plus b is equal to ln ax plus b. So what I will do is that I'll repeat this line in the next slide. So this is what we have. So what we would want to do right now is to divide through by a. Okay, we divide through by a. When that happens, we have ln ax plus b all over a plus c. Okay, so whenever we integrate ax plus b, our answer is the length of the denominator, okay, the length of the denominator divided by the coefficient of the x term. You are done. The length of the denominator divided by the coefficient of the x term, and you are done. Okay, then don't forget your plus c is very, very important. So let's take an example. We have 7 over 2x minus 1. Okay, so the first thing that you would want to do is write 7, that you pull it out, so you have 7, and now you have 1 over 2x minus 1, and it's very similar to 1 over ax plus b. Okay, so the answer is simply length of this denominator divided by the coefficient, which is what, 2. Okay, they will multiply by 7, so that's what we are going to do. Right, so like I said, it is the length of this denominator, which is 2x minus 1 divided by the coefficient of the x term, which is 2. Okay, the 7 is there, don't forget, so times 7. And this, let's repeat on the next slide. So what happens is that we multiply, and then we will get 7 ln 2x minus 1 all over 2 plus c, and then we are done. Okay, very, very easy. Right, we have another example. So whenever you are given this, I would advise you to expand this bracket. Okay, expand before you try to integrate. Okay, so let's expand. So our expansion gives us this, but how did we get this? So it is the first number squared, that is 25. Okay, then you multiply 5 by negative 3 over x, and that will give you negative 15 over x times 2. Okay, times 2, that will give you 30 for x. Okay, then you integrate the whole of this, and that will be 9 over x squared. Okay, 9 over x squared. So that is how come we got this. Right, so it will be easier for you to integrate the 25, integrate this, integrate that separately. Okay, but when your study of integration improves, you can do this without going through lots of processes. Right, so when you integrate 25, you get 25x. Okay, remember that the integral of a constant is a function, so you have 25x. Then when you remember that this is the same as 30 times 1 over x, and 1 over x, the integral of 1 over x is what? Ln x. So we multiply by the 30, hence we have negative 30 ln x. Now with this one, you could have integrated it directly, but since I don't want to confuse you, I decided to keep it the integral of, then I will write this in the indices form, which is 9x raised to the power negative 2. Okay, so that we can easily integrate. Okay, so what we will do is that we will add 1 to the power and divide by negative 2 plus 1. Right, so when we do that, this is what we have. When you integrate 9x raised to the power negative 2, you are going to get negative 9 over x. Okay, and then you rearrange beautifully. So your 25x is here, your negative 30 ln x is there, and when you integrate this, this is what you have, plus c. Okay, and then you are done.